Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, matriculants, for the majority of your high school life, you've only been dealing with quadratic equations. But in matric, particularly in grade 12 calculus, we start to talk about cubic equations and cubic expressions. We no longer just talk about quadratic ones. Now, this video is going to teach you about two really important theorems that help us to work with cubic polynomials. This is the Remainder Theorem and the Factor Theorem. This is part 7 of our calculus series, so make sure you've watched the first 6 videos, but let's jump right into it to talk about the Remainder Theorem. Now, the Remainder Theorem, if I were to simplify it, and to be quite honest, even this statement is not too simplified, but I promise you it's only the statement that's not simplified. The application of it is actually very easy, as you'll see. The remainder theorem tells us that if you're given a polynomial called f of x and you divided it by a linear function called h of x, and let's say h of x had the equation cx minus d, then you could find the remainder of dividing f by h. You could find the remainder by just plugging in d over c as an x value to f. Now, where does the d over c come from? Well, if we took h of x and equated it to 0 and tried to solve for x, you'd move the d to that side to get positive d is equal to cx. You'd divide both sides by c to get therefore that x is equal to d over c. So we find this d over c by just equating the linear equation or the linear function to 0. Now, I know this sounds like a lot of nonsense. Let's look at a couple of examples, and I promise it's going to make much more sense. Here's a first example. Use the remainder theorem to determine the remainder r when f of x is divided by h of x. So here's f of x. We want to divide it by h of x. So in order to do that, we're not going to go ahead and do a long process of long division somehow. We're going to equate the linear equation to 0. So we're going to say 0 is equal to x minus 1. And when you do that, you'd get that therefore x is equal to 1. And according to the theorem, f of 1 should give us what the remainder is. So the remainder should be equal to f of 1. The remainder r is equal to f of 1, meaning it's equal to 1 cubed plus 4 times 1 squared plus 11 times 1 minus 5. Okay, now go ahead and put this in my calculator. 1 cubed plus 4 times 1 squared plus 11 times 1 minus 5. The answer here is 11, and so the remainder is 11. That's all it is. It's telling us that when you're given a polynomial called f of x and you're asked to divide by h of x, then the remainder can be found by just plugging in d over c in place of x in the f equation. And we found d over c by just equating h of x to 0. Great. Let's look at another example. So in this example, the question is still the same. What would the remainder be if you divided f of x here with the linear function h of x? In order to find that, you'd first equate h of x to 0. 0 is equal to 2x minus 1. Moving 1 to the other side, we have 1 is equal to 2x, and if I divide both sides by 2, I'd get that x is equal to a half. Now, we can find the remainder r by just plugging in an x value of a half in place of x. So 2 into a half to the power of 3 minus 5 into a half to the power of 2 plus 8. And we'd get that the remainder r, I'll just put this in my calculator, 2 times a half to the power of 3 minus 5 times a half to the power of 2 plus 8. This gives me 7, and so the remainder is 7. Let's look at this example. How can we find the remainder here? We can find the remainder by equating h of x to 0. Right? We can say h of x is equal to 0. In other words, x plus 2 is equal to 0. X is equal to negative 2. I can find the remainder r by plugging in an x value of minus 2 into f. So 4 times negative 2 cubed plus 5 into negative 2 all squared plus 6 into negative 2 minus 1. Great, I'm going to put this in my calculator. 4 into negative 2 all cubed plus 5 into negative 2 all squared plus 6 into negative 2 minus 1. This gives me negative 25. The remainder R is negative 25. So that's the remainder theorem. And these words here might sound like they're complicated, but it's not really complicated. We're saying if you're dividing a polynomial f of x by a linear function h of x, to find the remainder, equate h of x to 0 and plug in the x value you get into f of x, and that'll give you the remainder. Let's now talk about the second really important theorem for cubic polynomials, which is the factor. The factor theorem tells us the following: that if you're given f of x and you plug in some x value, maybe c, and you get 0, then x minus c must be a factor. It's actually an extension of the remainder theorem, but it's telling us something that we've always known, that if you take a number, let's say 20, and you divide it by, say, 5, the answer you get is 4, and the remainder is 0. If the remainder is 0, then 5, the one we divided by, must be a factor of 20. Whenever you divide something by something else and get no remainder, that means that something else is a factor of the something. Okay, so if you take 100 divided by 2, you get 50 and no remainders. That means 2 must be a factor of 100. That's all this is telling us. We know that if we plug in f of c, that can help us find the remainder if the function was x minus c. Because remember, if you have x minus c is equal to 0, then x is equal to c. If you plug in that, you get what the remainder is. Okay, so just keep in mind that if f of c is 0, then x minus c must be a factor. So what we're going to be doing is we're going to be trying to find a number that makes the expression 0. So for example, we're just going to check whether minus 1, 0, 1, or minus 2 and 2 make this expression 0 in order to find which one is a factor. So the question here says, find the factor. What I'm going to do is I'm going to try and find f of minus 2 first, which is minus 2 cubed plus minus 2 squared minus 17 into minus 2 plus 15. I'm going to put this in my calculator, and I suggest you do it with me. Just try to put this in your calculator. Pause the video. So negative 2 all cubed plus negative 2 squared minus 17 into negative 2 plus 15. Okay, this is giving me 45. So that's not 0. I'm going to try another one. Let's try minus 1. I'm going to try minus 1 there. Just replace the 2 with a 1. Minus 1. Yeah. Okay, now that gives me 32. It's not 0. Okay, if I try to put 0, 0, 0, 0, I'll get 15. Okay, so f of 0 is 15. Let's try f of 1. Remember, the hope is we want to get to a 0. We want to find the c that makes f of x 0. Great. When I try f of 1, I get 0. What does that mean? That means that x minus 1 is a factor. That's what the factor theorem teaches us. That if f of c is 0, then x minus c is a factor. Okay, so you just try the different integers like minus 2, minus 1, 0, 1, 2, and you try to see the one that gives you a factor, or that makes the expression 0, and that means x minus that number is a factor. Great, let's look at another. So in this example here, we want to find the factor of f of x is equal to x cubed minus 2x squared minus 5x plus 6. So I'll try to find f of minus 1. Minus 1 cubed minus 2 into minus 1 squared minus 5 into minus 1 plus 6. And put this in my calculator. Minus 1 all cubed minus 2 into minus 1 squared minus 5 into negative 1 plus 6. This gives me 8. I'll try here f of 0, but that's going to give me 6. Okay, then I'll try here f of 1. 1 cubed minus 2 into 1 squared minus 5 into 1 plus 6. And great, that gives us 0. That means x minus 1 is equal to 0. Let's try another one. Let's try here f of negative 1. So I'm going to put negative 1 cubed plus negative 1 cubed plus negative 1 squared minus 9 into negative 1 minus 9. Oh, this gives me 0. That means x minus negative 1 is a factor. In other words, x plus 1 is a factor. Okay, why? Well, because if f of c is 0, then x minus c is a factor. In this case, f of minus 1 was a factor, so minus 1 made f 0, so x plus 1 was a factor. Alright, matriculants, in the next video, we're going to be looking at how to factorize a cubic polynomial. Just a reminder that all the notes to these videos are linked in the description box below. So if you want to revise, if you want to save the notes and all of that, it's all saved in the description box below. Please give the video a like, please subscribe, please comment. I'll see you in the next